some other formula we've gone through in class. Alright, now getting on to our last topic for today, we're having a look at electrostatics. So, electrostatics is moving on to topic 2, which is electromagnetism. So, electromagnetism is one of those topics that most people do not like, which is understandable, alright? Most people don't like it, and in my personal opinion, I do actually really like electrostatics. I find it really interesting, it's really cool, but it can get a little bit challenging at times, alright? So, just a few tips from somebody who has sat the externals, obviously. You'll typically see electromagnetism questions be very present. All right, there'll be a lot of electromagnetism questions on an exam, and there'll be at least one of them that is pretty complex. All right, so at least one of them will be kind of hard. So, what I'd recommend for your whole electromagnetism topic is make sure that you please practice difficult questions. Alright? Go through your textbook, go through any exercise books you can find, anything at all, and practice difficult questions for electromagnetism. Alright? Because you will need it. Okay? Don't just kind of be satisfied with kind of having a subpar understanding. If you feel like you don't really get something, make sure you ask for help or trying to figure out the answer yourself. Make sure that you understand this stuff, alright? Because similarly as well, the electrostatics and electromagnetism topics are a little bit more counterintuitive than our previous topic, which is on motion. So getting into like projectile motion and like circular motion and all that kind of stuff, we experience that more in everyday life. So answering questions is a little bit more straightforward because you can kind of guess what an answer would be, you know. It makes a little bit more sense. You know, there's just everyday examples, driving around a roundabout, you know, throwing a ball, that kind of thing. It doesn't feel like a new context as well as new content. And a lot of the things that happen are easier to remember because they make a lot of sense. You know, it's easier to remember the maximum height occurs when the velocity in the y direction is equal to 0. However, getting into electromagnetism, a lot of the stuff is a little bit more counterintuitive. So, please make sure that you're putting your effort into electromagnetism. Don't leave it until the last minute, alright? When you're learning it in class, I know you probably haven't gotten to it yet, but when you're learning it in class, please make sure that you're really paying attention. You're asking your teacher questions if you can, asking your friends questions, that kind of thing, talking about it amongst yourself, because it isn't one of those things that you want to leave to the last minute. Alright, projectile motion, yeah, you can definitely leave to the last minute. Because it's just kind of, it's not too difficult. Electromagnetism, though, is a bit of a different story. Alright, with that massive precursor, and I feel like I have definitely stressed you out a little bit, let's get started. So the first topic that you do for electromagnetism is electrostatics. And before we actually get into the electrostatics content, I just want to kind of explain a quick concept that really helps to understand the electromagnetism topic as a whole. Alright, so there are kind of three main topics that we talk about in electromagnetism. We have electrostatics, magnetism, and electromagnetism. So electrostatics, magnetism, and electromagnetism. Electrostatics is where we have charged particles. You know, like electrons, protons, that kind of thing. We have particles that have electric charge, and they're just kind of sitting around, not doing anything, right? And that's why we call it electric, statics. Remember, static means, in some cases, like, not moving. I'm not actually sure if that's why it's called that, but that's how I remember it. Electrostatic. So not doing anything. You're static. So, um, magnetism is where we have moving electric charges. So instead of just having a few electrons sitting around, we now have electrons moving. And when our electrons are moving, that creates a magnetic field. So we have electrostatics, where we just have electric charge lying around. When our charge is moving, like when it's going down a wire, when it's being transferred around, that kind of thing, then we create a magnetic field, right? So electric charges lying around creates an electric field. Moving electric charges create a magnetic field, and this is where magnets are going to be getting involved and getting, moved around and that kind of thing. The next topic you're going to look at is electromagnetism. So electromagnetism is when the magnetic field is changing. I won't get into too much of this today just because it's not on the schedule, but it's essentially kind of like just a tier list, right? So we have electrostatics, electric charge staying still, magnetism where we have moving electric charge, electromagnetism when we have changing magnetic fields. By changing, I mean the strength is changing, or like where it is changing, or the direction of the magnetic field is changing, and that kind of thing. All right? Okay, now that you understand kind of like the main topics we're looking at, let's start with the first one, which is electrostatics. So, Coulomb's law describes the relationship of the magnitude of the electrostatic force exerted by one point charge on another point charge. So, this is Coulomb's laws here. We have F equals, and we have our constant, which we usually just write as K, and this is on your formula sheet, so don't worry about remembering it, is equal to the two charges, the magnitude of the two charges in unit coulombs, divided by r, the distance between them squared. So, this is how we determine the force between two charges. The next thing that we're looking at, and that you need to know, is drawing electric field lines. So, the direction is in the line joining the charges. Right? So if the charges have opposite signs, then they're going to be attracted to each other. And if the charges have the same signs, they're going to be repulsed from each other. The other thing you know is to draw electric field lines. We always draw them in the direction that a positive charge would move in. So say we have a positive charge and a negative charge. How would we represent the electric field between them? Well, we have to think about, where would a positive charge move? A positive charge would move towards a negative charge. So our field lines are going to look like this. And you can kind of draw them however you'd like. Right, like this. Now, think about another example. What if we had two positive charges? Where would a positive charge move in these scenarios? Well, they'd move away from each other. Right? So this is what our electric field lines will look like. So can you see what I'm saying? You need to look at what direction a positive charge would move in and draw the arrows in those directions. Alright, let's get on to an example of Coulomb's law. So, calculate the magnitude of the electric force between two electrons placed 1 millimeter apart. So we have force equals K QQ on R squared. So K, remember, is 9 times 10 to the negative 9. Sorry, to the 9. Right? Our two charges are going to be 1.6 times 10 to the negative 19. Because we're going to be multiplying them by each other, we can just square them. One thing you might notice is that I didn't include the negative there. So when you're including charges in these equations, you don't actually need the negative. You don't need to put that in there. You can just kind of forget about it. And then we're going to be dividing by the distance between them. So 1 millimeter we need to put into meters. So how many millimeters are in a meter? Well, it's 10 millimeters in a centimeter and 100 centimeters in a millimeter. So we'll have 1 over 1,000 squared. So let's just quickly calculate what we get here. So we get 2.304 times 10 to the negative 28 newtons.